here's a plot of position versus time for some object. Let's see what we can figure out from it. So first of all, we see that the vertical axis is position and the horizontal axis is time. And first of all, we can find the starting value at time equals 0 is 4 meters. Each of these tick marks is 1 meter. So that would be my x naught is equal to 4 meters. Okay, so now I can see that this is a straight line graph. And what that tells me is from the slope, well, the slope is negative, right? So the negative slope means negative velocity. And that slope is constant, right? So it's a straight line, so the steepness is the same everywhere. So that means that I have a constant velocity. Right? So I can write constant. Negative constant velocity. Okay, and since I have pretty clear tick marks here, I can even calculate that velocity. Right? So my velocity, because I know it's constant, I can say, really it's the average velocity, but because that's constant, it's the same thing. So the velocity is the change in position over the change in time. So I could say, well, here at 4 seconds, I can say that the position is 0 meters. So that's going to give me 0 minus the starting position, which is 4 meters, so 0 minus 4 meters. And that change in time is 4 seconds. So that's going to give me that my constant velocity is equal to negative 4 divided by 4, which is negative 1 meters per second. And now without a picture, I don't really know what positive or negative means, but this might be, if this was horizontal motion, I would say it's moving negative 1 meters per second in the negative direction, which might be, to the left if we use our kind of typical definitions. Right? And because that velocity is constant, that means that my acceleration is 0 meters per second squared. Right? So I could just draw a quick sketch here for this velocity plot, right? So velocity versus time. I can say, okay, so then that's just going to be a straight horizontal line at negative 1, right? So I would just, velocity, I got to give my units, meters per second, and that's at negative 1. And that's constant. And I could, if I wanted to, I could sketch my acceleration versus time plot, but this is even more boring. Acceleration, which is meters per second squared. Time, of course, is in seconds for both of these. I would just put, helps to have an additional color. I would just put a horizontal line right at 0. So now I often hear students call this a constant acceleration, and that's true, but you need to be more specific. It's not just constant, it is equal to 0. The velocity is constant, and it's a value of negative 1 meters per second. So there's lots of numbers that are constant, not just 0. All right, so that was pretty simple motion. Let's go on to something more interesting. So let me sketch a quick plot here. So again, like this. Now this is going to be, well, let me go ahead and draw the graph. Same shape, but very different graph because what I'm plotting here is now velocity versus time. Okay, so let me give myself some tick marks here. So again, I'll make that 4 tick marks there, 3, there we go. Okay, so I have velocity versus time graph. So even though this looks the same, because this is labeled as a different quantity, it's going to describe a very different motion. Right, so now, first of all, if I could get my, try and get variables out of this, now the intercept value here, that's v naught. That's my velocity at the start of the motion, and that is, based on this number of tick marks, that's 4 meters per second. And I can tell that my acceleration is not 0. And my acceleration, because the slope of this, again, negative slope, means negative acceleration in this case. The slope of the velocity versus time graph. And again, that's a constant acceleration. So the slope of the velocity versus time graph is the acceleration. So we have a negative constant value acceleration. Okay, now, does that mean speeding up or slowing down? That's actually a trick question in this case, because let's look at what's happening in these different regions. So if I look at the beginning of the motion, here, the velocity is positive, but we have a negative acceleration. A is negative. So that means when they have different signs, velocity is positive, acceleration is negative, that means slowing down. Okay, so it starts at some positive velocity. And we can also just tell by looking, you could look at the slope to find the acceleration, or you could just say, well, here there's some positive value, and then at some later time, there's a positive value, which is a smaller magnitude. Right, so we're getting closer to 0 velocity. That means slowing down. Right, and then over in this region of the graph, the velocity is negative, but the acceleration is still negative. So that means speeding up. Right, so the acceleration didn't change at all. We had a negative acceleration at the beginning, a negative acceleration at the end. We went from slowing down to speeding up. And that's because in between we had a velocity of 0. And whenever you have a velocity of 0, you're either stopping, but in this case, you're changing directions. Right? So I should say it the other way around. Whenever you change directions, your velocity becomes 0 momentarily. Okay, so what I can say is that this object starts out moving in the positive direction. It has a positive velocity. It slows down, eventually changes directions, and then it starts moving in the negative direction when the velocity is negative, and when it does that, it speeds up. Right? So now I have a description of the motion. It starts out moving in the positive direction, slows down, turns around, and speeds up while moving in the negative direction. So I can make a plot of what that the position versus time looks like. Right? So for that same motion, position in meters, and I'll do time like this, time in seconds. How many? I need 5 seconds there. So 1, 2, 3, 4, 5. Now, the thing that I can't tell from the velocity versus time graph is what the starting position is. But usually we care about the change in displacement. So I'm just going to assume, I'll define, because I wasn't giving any other information, I'll define the starting position to be 0. Right, so now I need to make a plot where we start at 0. I'm going to have a positive velocity. So that means that I'm moving in the positive direction. At time equals 3 seconds, I'm going to turn around and move back in the other direction. Right, so slowing down, turning around, and then speeding back up, something like that. Right, so here we can see that's the turnaround point. Right, so it's pretty clear to see in the position versus time graph that's as far as you get. But we also can say, well, the slope of the position versus time graph at that point is 0. So the slope which is always changing, the slope equals 0 here. That means that the velocity is equal to 0 at time equals 3 seconds, which is what we saw from the plot above. The velocity was equal to 0 at time equals 3 seconds. Okay, so that's position versus time. We can see that. And the other thing that we can see is how it's slowing down, right? If we look at the slope at the beginning of the motion, it's pretty steep there, but then it's less steep as we get toward the turnaround point, and then it's speeding up, right? It's kind of less steep there in a negative sense, and then more steep as we get to that point. So we can see that all matches up with the information that we got from the velocity versus time graph. Now, if we go back and look at the velocity versus time graph, I can see that the 2 points that I can find. Okay, so I can say that my V naught was 4 meters per second. At some later time that I can easily find in the graph, the velocity was 0 meters per second, and that was at time equals 3 seconds. So at time equals 0, I had the starting velocity of 4 meters per second. So I can actually get a number for the acceleration, which I know is going to be a negative value, so that'll help me check. So again, that's change in velocity over change in time. So change in velocity so that's change in velocity over change in time. That change in velocity is v minus v naught, and that's just going to be over time because the starting time was 0. So I get 0 meters per second minus 4 meters per second divided by 3 seconds. So that gives me negative 1.3 rounding to the nearest. Negative 1.3 rounding to the nearest sig fig meters per second squared. So again, I could make a plot for that acceleration versus time. It's not super interesting. Acceleration is in meters per second squared. Time is in seconds. And again, we're going to have this constant value that's not 0. It's some negative value. And I can put that marker over there. Okay, so you should be able to start with either position versus time plot or an acceleration versus time, position versus time plot or velocity versus time plot, and be able to figure out what the other plots look like and give a description of this motion.